Hi class. Today we're going to look at Chapter 3, Lesson 2. Also, it's a part of Chapter 4 and Lesson 7 on rational numbers and the real number system. Our objective is how to write rational numbers as fractions and how to identify and classify rational numbers. A rational number is any number that can be written in the form of A over B, where both A and B are integers and B cannot equal 0. Now, what we mean by integers is that it can be either a positive or a negative number, and B could be a positive or a negative number. But B cannot ever be 0, because any number that divides into 0 is undefined. We cannot evaluate that. A can be 0, so that would be fine, but B has to follow that rule. Here is a chart on rational numbers. So as you can tell, in the very center we have our natural numbers, which include any counting numbers. So 1, 2, 3, 4, all the way up to 10. Then we have our whole numbers. Whole numbers include the number 0. So natural numbers do not include the number 0, only whole numbers do. Then in our next are the integers. Integers are our negative numbers and our whole numbers and natural numbers, because an integer is both negative and positive. And then finally, as you can tell, with our rational numbers, we see that they are fractions, decimals, repeating decimals, and negative fractions. Go ahead and take a moment and identify a rational number that you can come up with and explain why it is a rational number. Now let's go through a few examples to identify all sets to which each number belongs. So in other words, label each classification for each value. Number 1, the number 16. The number 16 is a whole number, an integer, and of course a rational number. But most importantly, it is a whole number because it is a positive value. Now, for question number 2, we know that negative 2.54 or negative 2 54/100ths, that is a rational number. And the reason why it's a rational number is because it is a decimal value, even though it is a negative number as well. So we could include it as an integer, but it specifically fits in the category of just a rational number because it is a decimal. Then for number 3, as you can tell, 9 over 3 can be divided. So 9 divided by 3, you actually end up with the answer 3. So since we get the answer 3, the answer 3 is a whole number. And because it is a whole number, it's also an integer and a rational number because it fits in all those categories. Then for question number 4, we have 0 and 95/100ths repeating, because you notice we have a repeating bar over our value. So this is a rational number. Because it is a repeating number, it only fits in that category. For question number 5, we have negative 4. Negative 4 is an integer, and it still fits in the category as a rational number. Then for number 6, 2.20200200002, we notice there is a pattern going on, but each time this pattern continues, we add another 0. That is not a rational number because the number does not repeat, and as you can tell, we see the ... means that it does not terminate. It continues on. We actually call this a irrational number. So this is irrational, and we will talk about that tomorrow. Go ahead and turn your notes over to the back now. In this section, we are writing rational numbers as fractions. So to write each number as a fraction, you simply put it either over a value of 1 or you convert the mixed number into an improper fraction. So for example 1, we have the number 13. So 13 simply just gets put over a value of 1. And now it has been converted to a fraction. So any whole number, you just put it over a value of 1, and that is the final fraction. For example number 2, we have 1 and 1/4. This is a mixed number, so we are going to convert it to an improper fraction. And the way we do that is by multiplying our whole number times the denominator. So 1 times 4, and you end up with 4, and then you add it to the numerator. So then whatever I get with the whole number times the denominator, I add that value to the numerator. So my final answer would simply be 5 over 4, because you want to keep that denominator. So the denominator does not change, just the numerator. Go ahead and practice the 3 guided practice problems now. In section B, we are going to write each decimal as a fraction or mixed number in simplest form. For step 1, place the decimal over a power of 10 according to the place value. And then of course, step 2, you need to reduce, and that simply means simplify. You need to simplify your fraction. So for example 1, we have 0 and 6 tenths. So we always want to pay attention to the place value. That is the key thing. So the place value of the 6 is the tens place. So I take the number 6 and I put it over 10. And as you can tell, 6 and 10 are both even numbers, so it can be reduced. And we are going to simplify it by dividing by 2, top and bottom. And we end up with 3 over 5. And that is my final answer. For example 2, I have 0 and 25 hundredths. So again, we look at that last digit's place value. The 5 is in the hundredths place. So I take the 25 and I put it over 100. And because 25 is a quarter of 100, that makes things a little bit easier. So I'm able to divide by 25, top and bottom, and my final answer is 1 over 4. Now for example 3, it's a little bit different because we do have a whole number, but we still pay attention to the last digit's place value to determine how our fraction is set up. We keep the whole number 1, so that is our mixed number. That 1 stays in the front. And then the 125, you put it over the thousands place because the 5 is in the thousands place. Now the next part, we have to reduce, and in this case, because we know it can be reduced by 5, we can check to see that 125 and 1000 can both be divided by 25 evenly, and that comes out to 5 over 40. And again, we can reduce it one more time, divide it by 5, and we end up with 1 over 8. And that is our final answer. Now go ahead and take a few minutes to answer the guided practice problems by converting our decimals as fractions or as mixed numbers. So pay very close attention to place value. So always look at the last digit to determine the place value. And then of course, don't forget, if you have a whole number, that means it's going to be a mixed number. In our last section, in section C, we are going to write each repeating decimal as a fraction in simplest form. Writing a repeating decimal is pretty simple. You still have to look at place value. So we find the place value of our digit, our ending digit. So in this case, the place value of the 4 is the tenths place. And since it's in the tenths place, and I want it to repeat, what I do is take the value of 10 and I subtract it by 1. So I'm just going to go 10 minus 1, and my answer is 9. So what happens is I keep that 4 in the numerator, but this time instead of putting it over a value of 10, I'm going to put it over a value of 9, because the 9 is going to continue that repetitious number of 0.4 repeating. So 4 over 9 is my final answer. Then for example 2, I have 0 and 12 hundredths repeating. So I'm going to do the same thing. I look at the ending digit, which is the 2, and that's the hundreds place. So just like what I did with the tens place, I'm going to actually subtract the 100 by 1, and I'm left with 99. So what happens is I keep the 12 as my numerator, but then this time my denominator is not going to be 100, it's going to be actually 99. So it's 12 over 99. But then I notice I can reduce the problem. So I can divide the top and the bottom by 3, and I end up with a value of 4 over 33. And that is my final answer. Now go ahead and go over the guided practice by answering questions 1 through 4. Make sure you pay attention again to place value, and don't forget, because you want it to repeat, you need to subtract one value away from that place value. And also, if you're writing a mixed number, pay very close attention if you have a whole number, to always put that in the front.